Hello, everyone. In this video, we will work on number 45 in 6.2. In this question, we would like to find the volume of the region rotated about the x-axis. We have two graphs that will bound the region. One is x minus 2 squared. Another one is gx equal to x. We need to identify these two functions in the pictures. All right. And then we need to decide whether to use a vertical slicing or horizontal slicing. I will suggest you to consider both, but here I will only show a horizontal approach. We draw horizontal line and try to slice from the bottom to top. Then this will give us an integral in a y value. Look at the pictures, then the y variable range from 0 to 4. Now it looks like we will have an integral something like this. Now we need to fill out the area function for the integrand. Go back to the pictures. If we rotate about the x-axis, look at the vertical bar we have there. After we rotate it, then do we get a disk, washer, or a shear? In this case, it seems to be a shear. All right. Then we consider shear method in a y value. According to the formula, it looks like this. We have two parameter functions, r of y and h of y. Now I draw a new pictures such that we can understand what's the meaning of this r of y and h of y. Ry is the distance between the horizontal bar and the axis that we are rotated about. Okay, now here I actually draw two horizontal bars here to explain it. No matter which one we use, it seems that the distance determined by y. That means r of y equal to y, because this ry just given by the height of y. Okay. However, the h function corresponds to the height of a shear. Now, this height, it seems that we will have this different situations if we consider different y domain. Indeed, we will find out that this is the critical line. Above 1 and below 1, we have two different situations. Okay, now let's split the integral into two parts, from 0, 1 and 1 to 4. As we mentioned, r of y, it doesn't really matter which case, always equal to y. Now, the first case, from 0 to 1, we determine hy. Right? I actually include here the height. All right. Now look at it. From 0 to 1 y variable, if we consider this, we can actually get the x variable. Also, for this dashed line, we can get another x variable. Indeed, this is obtained by solving the equation of the curve y equal to x minus 2 squared, solve x in terms of y. Then there are two possibilities. All right. This will correspond to the left and the right edge of this parabolic. Okay. So indeed, the difference between these two functions is exactly the height of the shear that we need. Okay. So that's why 2 square root of y is the hy we consider here. Now the second case for y variable between 1 and 4, all right, the height will be the difference between this, right, 2 plus square root of y minus y, because this time here, the distance, the height will just depends on the x coordinate. But this x coordinate is exactly y because this straight line is y equal to x. All right, so that's why we have a height function like this. Notice that determining the radius function and the height function is the key in this process. In particular here, we have to split the interval into several parts, right? And identify the expressions in each part. The next step is to plug in the data and then do the regular integral evaluation. And finally, we obtain an answer, all right? However, as long as we got this step, I think we are finishing 19% of the work, okay? The remaining part is just a standard exercise, right? It may be tedious, it may still take more time. However, it's not that difficult, okay? All right, so this is how we solve these questions. Now, I would like to give you a summary. To deal with a problem like this, usually we will utilize the slicing approach. And there are two possibilities, horizontal or vertical. If we consider horizontal slicing, right, we draw one or two horizontal bars there and indicate the arrow to see the direction we are slicing from bottom to top. So it will be an integral in y. Next, we need to figure out the particular shape when we rotate this horizontal bar, right? And we see a shear. Now we write down the shear method formula. The next will be the most challenging one, is to figure out the expression of the parameter functions involved in the integral. Okay, so this one requires you to understand where in the geometrics. Okay, so I think that's all for this question. Thanks for watching.